Today we're going to talk about matrix inverses. So suppose that A is a 3 by 3 invertible matrix. Remember what this will mean. Multiplying by a matrix is applying a function. So if AX is equal to B, then A inverse times B is going to be equal to X. Okay, and we can think of this like a cycle where A sends X, multiplying by A sends X to B, and multiplying by the inverse sends B to X. Okay, so how do we build this inverse matrix? Well, we know to write down a matrix, we want to know what does A inverse do to the vector 1, 0, 0. This will be our first column. We want to know what is A inverse times 0, 1, 0. This is our second column. And we want to know A inverse times 0, 0, 1. This will be our third column. Okay. All right. And so we want to know A inverse sends 1, 0, 0 to what vector X? Well, if we can think of writing this going the other way, A is going to be sending some unknown vector to the vector 1, 0, 0. Okay, so we can say, well, A times X1 equals 1, 0, 0. The solution to this will be our first column of A inverse. Similarly, A will send some unknown vector x2 to E2. The reason we're interested in this is going back the other way. A inverse times the vector 0, 1, 0 is going to be our second column. But we could calculate this by solving. We could find that second column by solving AX2 equals E2 or 0, 1, 0. And finally, our third column we get by solving AX3 equals E3. Okay. Same story. Now, in order to solve these, we calculate the augmented matrix, A augmented with E1, and we row reduce. A augmented with E2, and we row reduce. A augmented with E3, and we row reduce. And when we row reduce, we are going to find the identity matrix on the left, and we'll have X1 on the right, identity matrix on the left, X2 on the right, identity matrix on the left, X3 on the right. So rather than doing 3 separate calculations, what we do is instead we form what's called a superaugmented matrix. We're doing the same row reduction steps no matter what our augment is. So we just put in each one of these columns. So column 1 is E1, column 2 is E2, column 3 in the augment is E3. When we row reduce, on the left-hand side, we know that the reduced row echelon form of an invertible matrix A is going to be the identity. And on the right-hand side, what are we going to see? Well, our first column is going to row reduce to X1. Our second column will row reduce to X2. Our third column will row reduce to X3. And so this is going to be the identity augmented with our inverse matrix. We're going to take a look at this using Sage. Okay, so here we have this 3x3 example. It is invertible. We're going to find the inverse. And what we're going to do is form this super augmented matrix. And we're going to ask Sage to row reduce. And it will reduce to the identity matrix augmented with our inverse. So let's take a look at that. Notice here, we're going to have 3 rows and 6 columns because we have 3 left of the augment and 3 right of the augment. Okay. So let's form this matrix if I can find my mouse. Okay, so we have B is the matrix that has 3 rows and 6 columns. We're going to write in our entries 1, 2, 3, then our augment 1, 0, 0, 0, 2, 1, then our augment 0, 1, 0, and 2, 5, 4, then our augment 0, 0, 1. Next, we're going to ask for the reduced row echelon form of this matrix. And we can see our answer right away here. On the left-hand side, we see an identity matrix. And on the right-hand side, we see this inverse matrix, -3/5, -7/5, 4/5, -2/5, 2/5, 1/5. Okay. It is nice to have a computer here rather than having to do it by hand. Oops. Miswrote that. That last line should be 4/5, 1/5, -2/5. So in the next video, actually show how to do the row reduction by hand. That's a completely optional video if you're interested. All right, folks, very good.